So I've had a number of questions about how to do this question on the practice test. In particular, part C. What is the probability that more than 2 viruses will go undetected in a single day? There are a few ways to do this problem. There is also a bit of confusion between what are complementary events in this case. So be careful in your interpretation of the probabilities, what the complement of that event is, and the the notion of success and failure when you're considering a binomial distribution. So question 2, really like part A, right? It's the answer to that is binomial, right? It's binomial with n equals 13 and p equals 0.97. If more than 2 viruses are undetected, that means less than 11 viruses are detected. X is a probability of the virus being detected. So what we're asking for in this question, right, one interpretation is P X less than 11. This is equivalent to, because we have a discrete probability distribution, X less than or equal to 10, which is equal to the sum of Px equals 0 plus Px equals 1 plus blah, blah, blah plus Px equals 10, right? That's an expression to calculate. You can go ahead and evaluate these things from the binomial distribution, but it's a lot of summing, right? There's a lot of evaluations of the binomial distribution that you have to make, and thus it is prone to errors, especially if you're using a hand calculator. So let's use complementary events to rewrite this probability. The complement of x less than 11 is x greater than or equal to 11. Right, so I should write this is equal to 1 minus the probability that x is equal to 11 plus the probability that x is equal to 12 plus the probability that x equals 13. This is fewer things to evaluate, and thus it's less error prone. Let's use the binomial formula to write this out explicitly. And when you calculate this thing, you should get something quite small, I believe it's 0.006. So it's pretty unlikely that there's more than 2 viruses go undetected in a single day. That makes intuitive sense given that the probability of detecting a virus is 0.97, right? It's quite high. And that's how you do that question. There are a couple of different ways. You can obviously evaluate that bigger sum, px equals 0 plus px equals 1 plus px equals 10. You can also recast the entire problem and look at, say, a random variable y, which is the number of viruses that go undetected. This is distributed binomial 13 with probability 0.03. You can go ahead and construct the probability then that you'll detect more than 2 viruses in a day, or that, that you'll not detect more than 2 viruses in a day, as the sum of px equals 3 plus px equals 4 plus py equals 3 plus py equals 4 plus py equals 5, etc. up to 13. You can also evaluate that in a complementary sense. You should get the same answer. I recommend thinking about it this way because you're still thinking about the original variable that you've constructed, right? You're really thinking about the notion that the virus is detected as being a success in this case.